This module is about serverless computing. This is where we learn and understand about app services, containers versus virtual machines, and how do you host web applications in Azure Kubernetes services. We'll also understand the architectural aspects of Kubernetes and how the various entities in Kubernetes work with each other to provide an enterprise scale web application. Let's get started with app services. Let's start the discussion of serverless computing with App Service. Azure App Service is platform as a service that will let you create applications on an app service plan. Now, what is app service plan? App service plan is something that defines the set of compute requirements required for a web app to run. These compute resources are something similar to the conventional web hosting services. You can run multiple applications on the same app service plan. So when you create an app service plan in a certain region, you will be creating a set of compute resources in that particular region. And then you can go ahead and deploy applications, could be mobile apps or web applications on that app service plan. An app service plan is confined to a region. It is nothing but a virtual machine that is running behind the scenes for your application. But then it's just like a platform as service. You won't have much control on it as it is a PaaS service. However, you can control the size of the virtual machine, like small, medium, or large. The app service plan runs in number of tiers. So you have free tiers and shared tiers as well. So in a free and shared tier, an application receives CPU minutes on a shared virtual machine and it cannot be scaled out. In other tiers, which are more advanced tiers, an application can be scaled. So when you create an application in an app service, you put it into an app service plan. So when an application runs and it runs on all the virtual machine instances configured in an app service plan, and if multiple applications are in the same app service plan, they all share the same VM instances. Let's chat about different app service plan pricing tiers in the next lesson. Now that you know that the app service plan is some kind of a compute resource where you will be hosting your applications, you can potentially save money by putting multiple applications in one app service plan. You can continue to add applications to an existing plan as well. But keep in mind that all of these applications will be consuming resource on the same app service plan. That just means that overloading an app service plan will cause potential downtime for your new and existing applications. An application is resource intensive. So if there are lots of users and lots of connectors to that application, it will spike up the CPU and memory on that app service plan and may cause potential downtime to other applications. For that purpose, let's go ahead and understand the pricing tiers we have in the app service plan. So you got multiple tiers here. You got free, shared, basic, standard, premium, and isolated. As a matter of fact, let's go ahead and run this on the Azure subscription, create an app service, and then see how the pricing tier looks like. I'm currently logged into the Azure App Services. I'll click on this button which says Create App Service and walk you through the options to create a web app. And parallelly, while we do that, we'll take a look at the various pricing tiers we have. All right, so I'll select my subscription, select my resource group, let's say sales, and type my web app name. Make sure that the web app name is unique and nobody else in the world should have used the app name. So I'll call it as, let's say, creative app or something. And when I hit tab, it's going to automatically complete and do that checking for me. So if you got a green checkbox, we are ready to go. Okay, so now you're ready to publish your web application either as a runtime stack or as a Docker container as well. We'll learn more about containers and virtual machines and differences between them, Kubernetes, in the upcoming lessons in this module. For now, let's go ahead and select code and then runtime stack. You may probably select the platform on which you may want to, or your programmer may want to write the application on. Right? So if I select, let's say, Tomcat 9.0, my web application will be hosted on Tomcat 9.0. You may want to select operating system here, Linux or Windows. I'll choose Linux at this time. The region, I'll leave it as central US, but then you can choose the region which is closest to the users. And then finally, coming to the app service plan section, and this is the topic of discussion we have. Now, like I said, app service plan is something that will host my web application. And once an app service plan is created, I can have multiple applications hosted on the same app service plan. By default, the SKU and the size is Premium, V2, P1, V2, which gives me the specs as mentioned here. But let's say I want to change this pricing tier. This is where you would see the pricing tier that I just mentioned when we started this lesson. That we got different kinds of pricing tiers categorized as dev test, there's production, there's isolated. Let's talk about these. Now, F1 is the free tier. The usage is primarily for development environments and test environments. Now, how many web applications can you host on this one? Including, let's say, mobile applications and web apps and APIs that you want to run through this app service plan? The limit is 10. The maximum disk space that you get is 1 gigabyte. Of course, 1 GB may not be sufficient for 10 applications, but that's the limit. Moving to the next app plan, which is B1. It's the same use case here. You use it for dev and test environments. The maximum disk space that you get is 1 gig, but the number of web applications that you can host here is 100. So the limit, the upper limit or quota is 100 web applications, mobile, API, all inclusive. So these two plans that you see are the base plans. These are base tiers that run on same Azure virtual machines as other apps. So the concept of cloud computing is to have a common hardware for all virtual machines and for all customers as well. So some of the applications may belong to other customers. These tiers are intended to be used only for development and testing purposes. And that's why there is no SLA provided for free and shared service plans. So the F here stands for free and B stands for basic. Again, both of them are for dev and test environments. Let's move on to production workloads. Now, these are designed for running production workloads. So the pricing is based on the size and number of instances that you run. You get built-in network load balancing support, which automatically distributes traffic across instances. So I would like you to go ahead and check these options like P1, V2, P2, V2, etc. And as you toggle around these, the options underneath will also change. So you may also want to check at additional options. For example, S1, S2, and S3. S stands for standard and P stands for premium. When we talk about premium service plans, these are designed to provide enhanced performance for production applications. These premium plans have faster processors, SSD storage, and they have lots of memory ratio as compared to the standard ones. These premium plans also support higher scale via increased instance count while still providing all the advanced capabilities found in the standard plan. So that is standard and premium. Let's move on to the isolated section. So wherever you see I1, I2, and I3, they just mean isolated. What does that mean? The isolated service plans are designed to run mission critical workloads. These are required to run in a virtual network. The isolated plan will allow customers to run their app in a private, dedicated environment in an Azure data center using DV2 series virtual machines with faster processing, solid state drives, and lots of memory as compared to the standard ones. The private environment used with an isolated plan is also called as app service environment. Now, if you start looking closely at these features here, I just randomly clicked on I1. It just says that it's going to run within your own virtual network. That means you will have some control on the security groups, the routing, etc. And everything that the virtual network offers, including DNS, subnets, and all those nitty-gritties of a virtual network. Another thing to note is that when auto scaling happens, it will scale up to 100 instances. And that's not the only limit. You will get more than 100 instances if you request for it. 100 instances is just a upper limit or a quota assigned per subscription, but this can be modified upon request. To summarize this, you got basic plans, production workloads, which are then categorized as premium and standard, and then isolated for running your mission critical workloads that needs to have its own private network while getting the compute power like faster processors, solid state disks, and more memory per instance allocated per application. Now that we understand this, let's go ahead and understand app service scaling in the next lesson. Let's now take a look at the options that we have for scaling your web applications. You got two options for scaling. One is scaling up and the second one is scaling out. Let's understand the difference between these. When you plan to scale up, you get more CPU, memory, disk space, and all the extra features like dedicated virtual machines, maybe custom domains, certificates, staging slots, and more. You scale up by changing the pricing tier of the app service plan that your app belongs to. When you scale out, you are increasing the number of virtual machine instances that run your app. So let's say you got 5 virtual machines running your application, and when you scale out, you may go as much as 30 instances, depending on your pricing tier. App service environments in isolated tier further increases your scale out count to 100 instances. The scale instance count can be configured manually or automatically. Auto scaling is based on predefined rules and schedules. So you can define a rule and say that if the CPU goes above 70%, scale out. Or maybe you want to schedule the scaling at a particular hour of the day or a particular day in a week. So that's scaling up and scaling out. Just to summarize, scaling up is where you increase the computing power of the virtual machines running your applications. Scaling out is where you increase the number of virtual machines that are behind your web application. All right, now my web app called Creative app is created and it looks like there's a typo here. All right, so I'll just ignore that typo at this moment and continue with the demonstration of web app. So let's say my app called Creative app is ready, and what I want to show you is the auto scaling feature. So in continuation with the previous lessons, we were talking about scale out and scale up. So once your app is created in your lab environment, I suggest that you scroll down, and under settings section you will see something called scale up and scale out. If you click on scale up, we discussed about this and we did say that if you want to increase the specifications of your app service plan, then you would like to scale up. Now, when I was creating the web application, I did select B1. But at any point in time, let's say you would like to switch to production under P3V2, you got to select that and click on apply. So you will get all of these features that P3V2 has along with the compute power that P3V2 provides, which looks like it is 14 gigs DV2 series of compute equivalent and 840 total ACUs. So we don't have to memorize these, but just remember that you can switch between these options available, and not just these premium options. Remember, we got these standard options as well. So don't forget to click on these other recommended options. There's a small hyperlink here. So if you click on it, you get these standard options. All right. So let's go back to dev test, and I'll leave it as B1 right now. The reason why we are here is just to show you how you can scale up. On the other hand, there is scale out, which will increase the number of virtual machines that are running your web application, right? So this is set to manual scaling. So where is the auto scaling option? Why we do not have auto scaling option? Well, the reason why I do not have my auto scaling option here is because my app service plan does not support automatic scaling. Well, let's go back and see. So I'll click on scale up, and the option that I've selected is B1, which just supports manual scale. So to demonstrate this, I'm going to go to production and choose S1, which is supporting auto scaling. Every pricing tier under the production will support auto scaling. Yeah. So regardless of standard or premium, they're all supporting auto scaling. It's just the number of instances that auto scaling supports will change. For example, the premium will support 20 instances, whereas the standard will support 10 instances. And if you go to isolated from your memory, can you recollect how many instances does isolated support? Well, isolated supports up to 100 instances. Okay. So now what I'm going to do is select S1, click on apply, and change my app service plan to S1 standard. Once that's done, I'll go to scale out. And then now you see that there's a custom auto scale option. So I can write my own policies and rules that will trigger the scaling. Let's see how that works. So I'll click on custom scale, scroll down to the bottom a little bit. So this is my auto scaling name. Okay, it's a randomly generated scaling name. You can type your own as well. And then select the resource group for this. Now we've got two options: scale based on metric and scale to a specific instance count. So when should it scale? When should it create new virtual machines? So that is something you define in a rule. So I just clicked on this add rule option and something popped up on the right hand side. So what you can do is configure these scaling options. Okay. So there are different metrics that you can look at. By default, it selects CPU, but then you can say data in, data out, disk queue, and all the options that you have. So let's say I'm selecting or leaving it as CPU percentage and then scroll down to the bottom. So by selecting or leaving it as 70, I'm saying that if the CPU goes above 70%, create one instance. Okay. And that create one instance is something that you select here. So based on these values and fields that are there, you're saying that if the CPU is greater than 70 and the CPU utilization stays or goes above 70 for approximately 10 minutes, then increase the count by one instance. All right, that's what auto scaling does. So let's say there's a lot of traffic hitting your web application because there's a sale time and people are buying a lot of products from your web application that you built on Azure App Services. And because of that, the infrastructure behind the scenes for the web app, which is the app service plan, eats up all the CPU and memory, right? So when the CPU reaches this threshold, you're going to increase the number of virtual machines by the number that you define here. Okay, so that's what it is. And then there is cooldown period of 5 minutes. What does that mean? It means that for this period of time, the entire auto scaling will be shut down. So once an instance is created, right, it will take some time to come into production. There may be certain scripts running in the background. The virtual machine does not just appear or pop up like magic. It takes some time because the services behind the scenes must start, the scheduled tasks that are running must start, and must participate in the actual web traffic. And for that, you need some time, and that duration is something that you're specifying here, right? So once a VM is spin up, it will not do any further auto scaling for the next 5 minutes is cooldown period. All right, so I'll just click on add at this time. And then you got other options like minimum, maximum, and default. So the minimum number of instances that will stay in the app service plan is 1. And the maximum it can go up to is 2. So let's say if I type 20 here, will it let me go beyond that? No, because my app service plan does not support 20. Okay, so I'll switch it back to 10, which it will gracefully accept. Okay, so minimum is the minimum number of instances you have in the app service plan, and the maximum is the maximum number of instances that can be provisioned as a result of auto scaling. All right, so let's click on save. This will update the entire configuration, although doesn't take much time. It is pretty quick. So these are the scale up and scale out options. Hopefully you've understood this. If you have your own lab environment, an Azure test account, go ahead and look at these options, look around these radio buttons and understand what each checkbox means, what each radio button means, and that way you become a better Azure administrator. In the next lesson, let's go ahead and learn more about these features. For example, deployment slots and deployment center as well, which is very important from a development perspective. Metric based rules measure application load, and based on that, it will add or remove virtual machines. For example, the CPU goes above 50%, you will have virtual machines being created. On the other side, time based is also a schedule based. This will allow you to scale when you see time patterns in your load and want to scale before a possible load increase or decrease occurs. For example, you may want to trigger a webhook every 8 a.m. on Saturday in a given time zone. So this is where you can go ahead and select the start date, end date, and even time zone. Look at the other options you have. For example, you can also repeat the auto scaling on specific days at that particular time. So these are the two auto scaling options you should consider: metric based and time based. So let's go ahead and finish this wizard. This is where we left in one of the lessons earlier. So at this point, I've selected these attributes. For example, the name of the app is right here. Selected the runtime stack, operating system, region, and also the app service plan. What I'm going to do now is change the SKU and size to something lower than premium because we're just running test workloads and I really do not need premium V2. But then at any point in time, you can change these. And in the previous lesson, we did learn about the scaling option. So you got scale up and scale out. So when you switch between dev test to production, let's say you're switching between P1 V2 to P2 V2, what you're actually doing is you are scaling up. So that way you get more memory, more CPU, and more features that are associated with these tiers. Okay, so you are scaling up. Once we are done with this wizard and we are done with creation of the web app, we will go ahead and see how you can scale out. That means creating new virtual machines once there is certain load on the web application. All right, so I'll select dev test and stick to B1 where I can do manual scaling. So if you notice, under production you have automatic scaling, but under dev test you have manual scaling, right? So when there is a lot of load on your web instances, then you have to get into the configuration of the web app and manually scale it. But then anything production and above have the capability to automatically scale up to 20 instances because I've selected P1 V2. But then if you, let's say, go to isolated, you can scale up to 100 instances. This is something we spoke earlier as well, but I thought it's important to stress at this time. I'll go back to dev test, select B1, apply, and click on next, monitoring. This option here, which is application insights, is a very important feature for developers who would like to monitor live applications. So somebody who would like to identify the performance anomalies, identify the analytics of your applications. How is it behaving? How many users are connected to your application? What are their requests rates? What are the response times, failure rates? Are the users getting any exceptions, any error messages when accessing your application? Or if you'd like to get more metrics about your application, then you would like to go for application insights. It's a wonderful tool to count your user sessions, get the performance counter, and run all kinds of host diagnostics on your application. At this time, I will select no, click on next, move on to tags, and finally review and create. All right, now my create button is enabled. Click on create and it will take a moment to get that created for us. So I'll stop the video. In the next lesson, let's drill down to the features that we have in web app. So we'll talk more about scaling your application, auto scaling, an overview of various features that you have as far as continuous development is concerned, or deployment slots, or even security of an app service. Let's talk about Azure App Services. We know at this point that with Azure App Service, you can create websites, mobile backends, web APIs for any platform or any device. Applications run and scale with ease on both Windows and Linux based environments. You got different deployment choices. So you saw those deployment choices when we were creating a web application. Just for demonstration purposes, I'll click on add to show you those options. So you can deploy your application on .NET, on Node.js. Then there's PHP as well in this drop-down menu. You can develop on ASP.NET, and you got Python environments, HTML. You can also customize these web environments. The new options that we have now is Ruby and Python 3.8 version. With all of these choices, you have more options to choose Azure App Service as a placeholder to host your web application. Azure App Service supports multiple languages and frameworks. You can also run PowerShell and other scripts or executables or background services. Developers always look forward for integration into DevOps tools like Azure DevOps, GitHub, Bitbucket, Docker Hub, or even Azure Container Repository. You can do continuous integration and deployment because there is easy integration available with all the tools. We spoke about scalability earlier, so you can scale up or scale out manually or automatically. That means that you will be hosting your applications anywhere in Microsoft's global data center, and then the app services will promise a high availability for the hosted applications. You can choose from more than 50 connectors for the enterprise systems such as SAP, SaaS services such as Salesforce, and internet services such as Facebook. You can also access your on premise data using hybrid connections and Azure Virtual Networks. That means that although your web application is hosted in Azure, you can still have a private connection to your on premise. Security folks will be concerned about security of your web application and compliance as well. App Service is ISO, SOC, and PCI compliant. You will authenticate your users with Azure Active Directory or with a social login with either Google, Facebook, Twitter, and Microsoft. You can also have IP address restrictions here and manage all the service identities. There's an extensive list of application templates in the Azure Marketplace, so you can get templates from WordPress, Joomla, and even Drupal. Developers love to work on Visual Studio. With Azure Web Apps, you will have dedicated tools in Visual Studio that will streamline the creation of your work, deploying, as well as debugging. Azure Web Apps falls under the serverless portfolio. So you will be running a code or a script on demand without having to explicitly provision or manage infrastructure. That means that you just pay only for the compute time your code actually uses. Azure App Services is API and mobile friendly. That means you get all the platform and features required for authentication, offline data sync, push notifications, and several other features that you'll require for your mobile app. In the next lesson, let's go ahead and learn about more features that we have inside the app service that we just created. So I'm here in the Azure portal. My app name is Creative Apps. In this lesson, we'll go ahead and learn about certain important features that the developers would love to incorporate while developing their web applications. But before that, let's take a look at these options on the right hand side. Now, the URL or the endpoint for my web application is this URL right here. Okay, so once I click on this URL, it takes me to a default page that looks something like this. But then once you have your own custom code, your own HTML and CSS and JavaScripts, you will have your own page here. But this is a default page that you see. Going back to your web application, you may be thinking about how will you upload your own HTML content. Let's say you have developed something on your computer, on your local machine, you've developed a mobile app or maybe a small website. How would you upload it to Azure Web Apps? Well, you will use FTP. Now, this is one of the traditional options that developers used to follow. Just open up your favorite FTP tool, like FileZilla is the most prominent one. Developers use FileZilla to connect to an FTP server, and the FTP host name is the highlighted section right here. So you will type the FTP host name. What you will also need when connecting to an FTP server is a username and a password, right? So anybody who knows the FTP hostname cannot upload content to the FTP server. They need a user ID and password, and I'll tell you where to get that in a minute. But think about automation. Think about continuous integration and deployment. Well, DevOps is becoming a big buzzword these days, where integration with Azure DevOps services, GitHub, Bitbucket is pretty common. So Azure Portal provides the out-of-the-box continuous integration and deployment features. And the place where you can get it from is the Deployment Center under the Deployment section. So if I click on Deployment Center, you will see the various CI/CD tools that you can use along with app services. You can use Azure Repos, which works in conjunction with Azure DevOps services. You can integrate this with GitHub, Bitbucket, and also local Git repository that is running probably on your development machine. All of these are for automation purposes. So what's going to happen if you connect your app to GitHub, let's say? Well, you will be automatically synchronizing the code from GitHub to app services. So you do not have to do anything manually via FTP server. There's a lot of flexibility that you get with DevOps. You can define your own build and release processes that will compile your source code, run the tests, build a release, And also finally, deploy the release into your web app every time you commit the code into GitHub, for example. And all of this happens without any human intervention. This is what is called as continuous development. On the other side, there is something called as deployment, or automated deployment is something connected to continuous integration. Continuous integration is a process that is used to push out, let's say, new features and bug fixes in a fast and repetitive pattern with minimal impact on end users. Azure supports automated deployment directly from several sources, as you see here. It works with Azure DevOps, GitHub, Bitbucket. So let's say you're using Visual Studio Team services to write your code and build your code. You can directly integrate to work with Azure DevOps. Lots of organizations have started to work with GitHub. So Azure supports automated deployment using GitHub. So when you connect your GitHub repository to Azure for automated deployment, any changes you push to your production branch on the GitHub will be automatically deployed for you. There are lots of similarities between GitHub and Bitbucket. So if you're configuring automated deployment with Bitbucket, Azure Web App will support that too. But let's say your organization is not that automation friendly and you're doing a lot of manual deployments, you got certain choices right here. You got local Git and FTP. So let's say you want to go ahead and work with a local Git repository which is running somewhere on your development machine in your network. So I'll select local Git here, click on continue, and I will have the options to select who my build provider is. It could be Kudu engine. The K here stands for Kudu engine, or you can use Azure pipelines. You would use this when you have deployed an Azure DevOps server on your premise, right? So let's say I select Azure pipelines and click on continue, and then you have to select the Azure DevOps organization, location, and various other parameters that connect to your Azure DevOps servers. On the other side, you can also select FTP. So that ways you'll be able to upload your content directly to this FTP endpoint using the credentials specified here. Now these are app credentials, and you also have user credentials which can be specified explicitly. Okay. So Azure App Services provides both the options to upload your content, synchronize your content using automation CI/CD tools, or manually as well. Apart from that, there is Azure CLI. So if I launch the CLI from here, make enough space for myself, there are CLI tools available, and you can use AZ web app up command to upload your content manually to Azure App Services. Azure CLI web app up is a feature of the AZ command line interface that packages your application and deploys it. Azure Web App Up can also create a new app service web app for you if you haven't created one yet. You can also integrate the app services with Visual Studio and deploy it right from there. So these are the various deployment options that we have. Remember that there are manual methods right here using FTP, using local Git, and also using CLI. Then there are automated methods that are all listed right here. Let's take a look at deployment slots in the next lesson and how it will be beneficial for organizations that have multiple environments. Organizations usually have multiple environments. For example, they may have a staging environment and a production environment as well. In Azure App Services, we call them as deployment slots. So you will call the staging environment as a staging slot and a production environment as a production slot. Well, what are the advantages of having such slots? Well, if you have multiple environments, you can validate app changes in a staging environment slot before swapping it with a production slot. With that approach, you will have less complaints from your consumers. Deploying an application to a slot first and swapping it into production ensures that all instances of the slot are warmed up before being swapped into production. This will eliminate any downtime when you deploy your app. There's a wonderful option called as traffic redirection. This traffic redirection from prod to staging and staging to prod is also seamless, and no requests are dropped because of this swap operation. In production environments, you usually swap between staging and production to get the most current workloads delivered to your end users. The benefits of doing that is that if the changes swapped into a production slot are not as you expected, you can perform the same swap immediately to get back to your last known good site back. You can create a deployment slot from the app portal itself. So I'm here in the deployment slot section, and as you see, by default, my web application is hosted into a production slot. At this moment, 100% of the traffic is going to this particular app. But then, like I said, you can create another slot by clicking on the add slot button, give it a name. Let's call it as staging. And then you have the options to clone the settings of this staging slot from the production slot. So I've selected creative apps here and I click on add. It will take a moment to replicate all the settings we have from the production slot to staging. But keep in mind that the new deployment slots can be empty as well. In this scenario, we have chosen to clone it, but you can always keep it empty. When you clone a configuration from another deployment slot, the cloned configuration is editable. So you can always go back and edit this configuration. All right, so now I have two apps. One is in production and the second one is staging. All right, but at this point, as you see, 100% of the traffic is going to production, but then you can always say that 70% goes to prod and then 30% goes to staging environment. By doing so, you will have less complaints coming from the website consumers. So if you're testing a particular web feature or a new service in your web application, then you may want to redirect the traffic and say, okay, 20% of the traffic now goes to my staging environment. All right, so I'll click on save here. Okay, so now my workloads are ready to go to staging as well. So that means that the 20% of the traffic will go to staging and 80% goes to prod. You might have already noticed that there's a swap button here. Once I click on swap, you got the options to swap between source and target. So when I do that, the content in my source will be synchronized to target, and the content in my target will then get synchronized to source. So there are certain settings as well that get swapped, and there are certain things and certain settings that do not get swapped. Let's talk about that for a minute. So there are certain settings that get swapped, and they are any framework related settings. Could be WebSockets, could be 32 or 64-bit related settings, any application settings, connection strings, handler mappings, any public certificates that you might have used, web job contents, hybrid connections to your on-premise, or you might have integrated with your virtual network or even service endpoints. And if you have integrated with Azure CDN, the content delivery network, they will also get swapped. The settings that do not get swapped when you hit the swap button are any endpoints that you might have published or any custom domain names that are linked with your app service. Keep in mind that there are certain non-public certificates and TLS or SSL settings, they will also not get swapped. If you have done any auto scale related settings, web job schedulers, IP restrictions on your web application, always on features, diagnostic log settings of your web application, and cross origin resource sharing options for your web app will also not get swapped once you hit the swap button. Like you see, both of these deployment center and the deployment slots are very critical features for a developer to host an end-to-end continuous integration and continuous deployment for your web application. Like a cherry on the cake is the swap option where you can create multiple slots like production, staging, QA, and then redirect the traffic to those web applications appropriately. And once you hit the swap button, you will be able to make the configuration changes between the respective apps that you have. All right, that was a quick summary. In the next lesson, let's go ahead and learn how you can secure an app services and what options do we have inside the application to let you secure the tokens, manage the authenticated sessions, and how does identity information get handled inside an app service. When you create web applications or mobile applications, you need some kind of a method where users can be authenticated into your application. Traditionally, developers had to write cumbersome, complex code to integrate authentication and authorization modules into the web app. Azure App Service provides built in authentication and authorization support so you can sign in users and access data by writing minimal or no code in your web app. Secure authentication and authorization requires deep understanding of security, including federation, encryption, JSON Web Tokens, in short called as JWT, grant types, and so on. App Services provides these utilities so that you can spend more time and energy on providing business value to your customer. Let's understand how this works. The authentication and authorization modules runs in the same environment as your application code. So let's say you picked up Tomcat 9.0 or Python 3.8. The authentication and authorization module is going to run inside the same environment. When this particular module, authentication and authorization module, is enabled, every incoming HTTP request passes through it before being handled by your application code. This module handles several things on your app. For example, it will authenticate users with a particular service provider that you select here. The service providers that we have as on today are Azure Active Directory, Microsoft, Facebook, Google, and Twitter. These are also called as identity providers. It would also validate, store, and refresh the tokens that are provided by the user. It will manage the authenticated session and also inject identity information into request header. This module runs separately from your application code and is configured using the app settings that you see on the screen here. You do not need any SDKs or writing the code in a specific language. You don't even need to change the application code that you have already written in. Authentication and authorization are two different concepts. So once the authentication is completed, you would then get into authorization part. Let's understand the authorization behavior. In the Azure portal, you can configure app service authorizations with a number of behaviors. The first one is allowing anonymous requests. That means if I select this, no action is required. This option will defer authorization of unauthenticated traffic to your application code. For authenticated requests, App Service passes along authentication information in the HTTP headers. So this option will provide more flexibility in handling anonymous requests. It lets you present multiple sign-in providers to your users. But if you'd like to provide a specific identity provider to the user, you may want to select this. So this option is log in with a particular provider. Once you have selected an authenticated provider, let's say Facebook in this case, the app service will redirect all anonymous requests to that provider. In the previous lesson, we understood that if you would like to access your web application, this is the URL that you'll use, right? But there's a problem here. And the problem is that you may not want to use Azure Websites.net as the suffix. You may be dealing with some e-commerce products with your web application maybe, and you want to have a custom domain. Maybe call it as www.myproducts.com or something like that, right? So you would like to have your own custom name that is specific to the products or services that you're offering with this website. So you need to reserve a domain name. Traditionally, we used to do it with GoDaddy.com or Big Rock or one of the hosting providers. But Azure now provides a one-stop shop for you to go ahead and reserve your domain. Now, this can be done in the custom domain section. If you haven't purchased the domain already, you can go ahead and buy and reserve a name for yourself. This process here will enable you to manage your web application's domain name directly in the portal instead of going to a third-party site to manage it. Purchasing a domain and managing a domain has been made very simple using the portal. So Microsoft will be your domain registrar. You do not have to go and buy the domain with a third-party registrar. Now what you do here is in this box, you go ahead and search for the domain name. Now, in this example, we did say that I want to use a domain name like myproducts.com. All right. So you fill up all these details, contact information, privacy protection, whether you need it or not, and if you would like to have a www record. What it did in the background is search for this domain name. Call myproducts.com. Looks like somebody else has picked up this domain name and it has given me the following suggestion. So if you're happy with that, you select these and go ahead and fill up these fields and click on OK. That will help you get a domain name for your web app. All right, so I'll click on OK and close this. There's another second interesting point that I want to tell you is the DNS. You can go ahead and create DNS records that map the domain to your Azure web app. Well, that's the second option. The DNS uses the data records to map domain names into IP addresses. There are several types of DNS records. There's a record, there's a CNAME record, TXT record. But in this case, because it's an alias and you already have a URL here, so you will be creating a CNAME. But let's say you would like to create an A record instead of a CNAME. You can go to custom domains, and this is where your IP address is. So you can go to your DNS registrar and create a record for this IP address. The A record will map a domain name to the IP address. A CNAME, on the other hand, is mapping a domain name to another domain name. When I say another domain name, it is this which we already have right here, right? So you'll be mapping www.myproducts.com with the URL that you see here. One thing to keep in mind is that to use this service called as custom domains, you cannot use your app service plan in the free tier. It must be paid one. For example, if I go to scale up section and under dev test, I go ahead and select F1, I do not have custom domains, right? Instead, I go to production and select any one of these randomly. You will see custom domain and SSL right here. So you would not be able to use custom domain names in the basic F1 section, but the B1 does have that custom domain and an SSL section. So the only tier that does not have custom domains is F1. All right, that's about custom domains. In the next section, let's go ahead and chat about backups and how do you ensure that the backups are timely. You got the snapshots, and when there are any configuration changes or file corruption, how do you restore it? The backup and restore feature in Azure App Service will let you easily create app backups manually or on a schedule. You can configure the backups to be retained up to indefinite amount of time. You can restore the app to a snapshot of a previous state by overwriting the existing app or restoring to another app. So you may be thinking about the backup service and what actually gets backed up. Let's talk about that. The app service will back up information to an Azure storage account, and then it will go inside a container that you configure your app to use. The backup service in the app services will back up the app configuration, the file content, and the database connected to your app. So if you have connected to SQL database or Azure database for MySQL or the Azure database for Postgres and the MySQL option inside the app, it will take backup of that as well. But there are several things that you need to consider. The backup and restore feature requires the app service plan to be in the standard tier or in the premium tier. You cannot have it in free tier or basic tier and expect backup and restoration features. That's one. Another point is that you can configure backups manually or on a particular schedule that I'm going to show that in a minute when we are configuring the backups in the lab environment. The next point is you need to have the Azure storage account and the container in the same subscription as your application that you want to back up. After you have made one or more backups for your application, the backups are then visible on the container page of your storage account. In the storage account, each backup consists of a zip file that contains the backup data and also an XML file that contains the manifest of the zip file contents. You can unzip and browse these files if you want to access your backups without actually performing an application restore. Now, are these backups full backups or incremental backups or differential? Let's talk about that. Now, these backups which are done by the backup service is a full backup. That's done by default. So when a full backup is restored, all content on the site is replaced with whatever is there in the backup. So if a file is on the site, but it's not in the backup, then it will get deleted. Partial backups are supported, but partial backups allow you to choose exactly which files you want to back up. When a partial backup is restored, any content that is located in one of the blacklisted directories or any blacklisted file is left as it is. You restore partial backups of your site the same way you would restore a regular backup. Just like other backup services, here as well you can exclude files and folders that you do not want to take a backup. So, what is the maximum size of the backup? As on today, the backups can be up to 10 gigs of the application and database content cumulatively. Alright, that being said and done, let's go ahead and configure the backups in the Azure portal. Now that backup is not configured, and there's a setting option here which says backup is not configured, and click here to configure backup for your app. So I'll click on that. As we discussed earlier, all the backups that are taken for your app service will then go and sit inside the backup storage. So I need to configure a storage account. So I'll click on storage settings, and now what you'll see is all the storage accounts that you have so far. You can create a specific storage account for this purpose. But for this demonstration purposes, I will select the storage account that I have and then also select the container. Alright, so I'll click on select. Okay, the storage account is selected, the container is selected. Let's move on further. Now the next option will let you schedule a backup. If you toggle this to on, you will have the options here. What should be the frequency of the backups here, right? So do you want to back up every day, or toggle to this hours option and this will back up every hour? You can set the time of the day, a particular time zone, the retention period, which is 30 by default, and if you would like to keep at least one backup in the storage account. Then, if you scroll down, you have an option to choose whether you want to take a backup of your database or not. Okay, like we discussed earlier, you are taking a backup of the data of your web application plus the ones in your database. That means that the backup service in your application services is providing a one-stop shop for your backup and restore purposes.
Traditionally, if you had to install applications, then the first thing that we had to do is to create either a virtual machine or a physical machine. Once the machine is ready, you will then have the dependencies installed, and then the application sits on top of the dependencies. So we are here creating multiple layers, starting from the application, dependencies, then the operating system, and finally the hardware which it talks to. Now, containers and virtual machines have a similar resource isolation and allocation benefits, but they function a little bit differently because containers will virtualize the operating system. The virtual machines will virtualize the hardware. Containers are more portable and efficient. Now, as you see in the picture here, there is a container managing application like Docker, which can manage multiple containers. Each container will then host application and its dependencies. As you see in the picture, application 1, 2, 3 have different set of dependencies or binaries or libraries, but still they are sitting on the same virtual machine. They are isolated with the help of containers. The green, orange, and red boxes on the right-hand side are containers, whereas on the left-hand side, the same colors represent virtual machines. The one on the right side is a containers architecture, where we have multiple containers sitting on the same virtual machine. Although they are in the same virtual machine, they are still isolated. The dependencies is the one which the container handles. In this case, or in this example, it is the container managing application like a Docker engine, which will let the communication happen between the container and the hardware infrastructure. Containers and virtual machines used together provide a great deal of flexibility in deploying and managing the applications. So, containers are an abstraction at the application layer that will package the code and dependencies all together. Multiple containers can run on the same machine and share the operating system kernel with other containers. Containers take less space than virtual machine, whereas virtual machines are abstraction layers on the physical hardware, which can turn on server into many servers. The hypervisor will allow multiple virtual machines to run on a single machine. Each virtual machine includes a full copy of the operating system. the application, necessary binaries and libraries, which will take tens and hundreds of gigabytes together. Virtual machines can also be slow to boot. But if you look at containers, containers are very quick. They can handle several applications and require very less virtual machines and few operating systems. So containers and virtual machines have similar resource isolation but function differently because containers virtualize the operating system instead of virtualizing the hardware. Containers are portable, efficient, and very quick in running the application. So Docker. So container is a standard unit of software that will package your entire application code and its dependencies so that the application can run quickly and reliably on that virtual machine.
Hardware virtualization has made it possible to run multiple isolated instances of operating systems concurrently on the same physical hardware. Containers represent the next stage in the virtualization of the computing resources. Container based virtualization allows you to virtualize the operating system. This way, you can run multiple applications within the same instance of an operating system while maintaining the isolation between the applications. This means that containers within a virtual machine will provide functionality similar to that of a virtual machine within a physical server. To better understand this concept, let's go ahead and compare containers and virtual machines. As far as isolation is concerned, containers typically provide lightweight isolation from the host and other containers as well, but does not provide as strong a security boundary as a virtual machine. If you look at virtual machine, a virtual machine provides complete isolation from the host operating system and other virtual machines. And this is useful when a strong security boundary is critical, such as hosting applications from any competing companies on the same server or the same cluster. Operating system has two modes, right? The kernel mode and the user mode. When you're looking at containers, operating systems runs the user mode portion of the operating system and can be tailored to contain just the needed services for your application using fewer system resources. As far as virtual machines are concerned, it runs a complete operating system, including the kernel. And that's one reason it will require more system resources like memory, CPU, and storage. How do you deploy a container? And how do you deploy a virtual machine? You will deploy individual containers by using simple Docker command lines or even Kubernetes command lines. So you can deploy multiple containers by using an orchestration service such as Azure Kubernetes Service. When it comes to virtual machines, you will deploy individual virtual machines by using Windows Admin Center or Hyper-V or VMware or using PowerShell or using System Center Virtual Machine Manager. Every application needs some kind of a persistent storage. When it comes to containers in Azure, you will use Azure Disks for local storage for a single node, or you can even use Azure Files for storage that is shared by multiple nodes or servers. In the virtual machine world, you will be using a virtual hard disk for local storage for a single VM or an SMB file share for storage shared by multiple servers. Redundancy, fault tolerance, and resilience are key for any application. In case of containers, if a cluster node fails, any containers running on it are rapidly recreated by the orchestration service or another cluster node. When it comes to virtual machines, the virtual machines can fail over to another server in a cluster with the virtual machine's operating system restarting on the new server. And this means that for several use cases, container services will offer significant advantages over physical machines or even virtual machines. Let's talk about the advantages of containers in the next lesson. In the previous lesson, we used this word called as isolated. This was one of the feature sets of a container. Isolation means speed. Containers are small entities than virtual machines, which are rather big. And because they are big, it takes a lot of time to deploy a virtual machine as compared to containers that are small and fast. Isolation also means responsive. Their startup times are short. Isolation means versatility. Containers are portable between different platforms and also between different cloud vendors. And that's how they deliver various benefits. With all of these benefits, you get increased flexibility and speed when developing and sharing the application code. Containerization is one of the latest developments in the evolution of cloud computing. There are several organizations that are looking at a container as a means to improve their application lifecycle. So that's how they can streamline and accelerate application deployment. With containers, you can modernize your existing applications, create cloud native enterprise scale applications, and open your data center to work with cloud services. With containers, you get a simplified application testing platform, and the set of containers can take higher workload density, and that results in improved resource utilization. Containers are becoming a preferred way to package, deploy, and manage your cloud applications. That's only because they are lightweight software components that bundle the application, its dependencies, into a single image and run those isolated user environments on a traditional operating system, on a traditional server, or probably in a virtualized environment. Just to summarize, containers are where you can deploy your applications faster, simpler, and also incorporating the agile methodologies that we use today. In the next lesson, let's go ahead and learn about how Azure incorporates container into the service offering called as Azure Container Instances. In this lesson, let's go ahead and understand the importance of orchestration services. At this point, we know that containers have several advantages. We know that containers are small, the images that containers use can be spun up very quickly, dependencies that are packed inside a container, they all work together, they are resilient, so when one of them goes down, another one can come up quickly. They are scalable, so you can add new containers, and they are elastic in nature. But all of that is good thing about containers. Although containers have several advantages, they are not ready by themselves for an enterprise scale application. What we need is things like resiliency or ensuring that there's an active container always running. We also need things like load balancing, things like scaling, elasticity, or even adding and removing containers require something more than just a container engine and a host. They require an orchestrator. Let's go ahead and chat about orchestrators for a moment. A host is a single point of failure. So we need cluster hosts to have true resiliency so that if one host goes down, another host can be spun up to handle the missing load. Orchestrators also provide services like load balancers that enable running multiple containers of the same image. For example, you may have web service that scales out to multiple containers even though it is accessed by a single endpoint or port. Containers require a way to scale on demand without manually spinning up images, so an orchestrator can provide that ability to react to, let's say, CPU usage load or maybe other indicators to spin up new containers and hosts. Finally, orchestrators manage resiliency by automatically healing when containers crash. They will automatically bring up new containers, whether it's on an existing host or a new host within the cluster. One important aspect is that orchestrators also provide versioning, deployment, and rollback. In other words, as you stage new versions of containers, you are able to stage them in a way that minimizes or completely eliminates downtime. Let's talk about some of the popular orchestration services that are supported by Azure Container Services. The first one is Kubernetes. Kubernetes is a Google-based solution that's an open source system for automated deployment, scaling, and management of containerized applications. Mesos, DCOS, is another orchestration solution. It is called as a data center and operating system orchestration solution. So this is a mature open source product that's been around there for several years. Now, this organization did not start as a container management solution, but it does a fairly good job. And then finally, Docker. Today, Docker is a standard for containers. It has its own engine called as Docker Swarm that manages clusters of Docker hosts. Let's go ahead and work with containers on the Azure portal. Now, there are multiple ways of creating a container. One of them is to go to All Services and then in the search box here, type container, and then you will find container instances. The other easiest option is to just type container in the search box and you will find the same thing. There are other ways as well. For example, you can use an ARM template or a JSON template to build a container instance. In this case, I'll click on Add to create a container instance and follow through the wizard. I select my resource group and then type the container name as, let's say, web app. I will leave the region as it is and then explain image source. We know that image consists of the dependencies for the application itself, and if required, an operating system. That's what an image consists of. Microsoft has these sample images for us to go ahead and test the potential of container instances. So you got Azure Container Instance with a Hello World application. So this image will have the Linux operating system and the binaries required for this application to run. There's another one which has an Nginx application with Linux operating system, and there's a Windows Nano server with IIS configured. Keep in mind that these are just for testing purposes. I'm going to select Hello World here, but let's also try to understand the other two options. So you got Azure Container Registry. Let's say you got a complex application built, and then you want to pack that application into a single image, including its operating system and dependencies. Then you will have to keep it in some kind of a repository. That repository is nothing but your Azure Container Registry. I'm going to deviate for a moment and then type Container Registry here, and then you will see that in the drop down menu here in this box. So if I click on it, you'll land up in the Container Registry. You can go ahead and create a container registry and follow through this wizard. Now, once the registry is created, you're ready to host all the images inside this registry or repository. You can use those images to create container instances from ACI. Okay, we are back here. We have selected Azure Container Registry, but then since we do not have any repositories or registries in the ACR, we don't have anything in the drop-down menu. There is another third-party service called as Docker Hub. It is pretty famous and a lot of developers use Docker Hub to host their images. Now you can use a public repository or a private repository. Keep in mind that private registries are charged and it's not free, whereas public repositories are free of cost. So if you know your Docker Hub URL in the public repository, you can just type that URL here. Okay. Now in this case, I will select Quick Images, and then in the drop down I will leave it as ACI Hello World. Next, the size. You have multiple variations to choose from. Number of CPU cores that you would like to allocate to your container, amount of memory that you would like to allocate to your container, and if there are any graphic based applications that you're running on your container, then you may want to select those options from the drop down menu. All right, so at this time, since this is a test use case, I will leave it as 1 vCPU and 1.5 gigs of memory. Moving on to the networking part. Containers can have a public or an external facing IP address, and there can be multiple ports that it can be exposed on. You can also assign a DNS label, which is a fully qualified domain name for your web application. This DNS label can then be used by the external clients to reach a container web application. So what you're essentially doing is that you're exposing the container on a particular port on a particular IP address with this DNS name. As you see, you got other options as well. You can choose not to have an IP address at all, or have a private IP address to have it routable within your networks in Azure, or keep it public. All right. So I will mark it as public at this time and call it as webapp.northeurope.azurecontainer.io. All right. So I'm exposing it on port number 80. But if you have certificates and you would like to encrypt it, you may want to choose 443. Okay. You can have multiple ports as well, but at this time I'll leave it as 80. Click on next and then check these advanced options. Containers are like small instances that run and host your web application. Now, if there is some kind of a problem, what would you like to do? What is your restart policy is determined here. So when containers fail, would you like them to restart? Or you can leave it as never, so that the containers will never restart even if there is a problem, or choose always. Okay, so I will leave it as on failure, which is what's recommended. Let's talk about environment variables. Setting the environment variables in your container instances allows you to provide dynamic configuration for your application or probably the script as well that is running in the container. You would essentially pass the key and its value as an environment variable. For example, you can say number equals 5 or max value equals 20 or case equals true. So I'm just typing randomly some values here, and these values can then be used in our configuration of an application or inside the script. So I do not have to specify these keys 100 times and the respective values another 100 times in the script. So they will just refer to these environment variables. Usage of environment variables is not new. We have been using these in operating systems and in applications as well. But here in container instances, this is one of the methods to pass the environment variables. Moving forward, when we learn about creating container instances using CLI, I'll show you how you can pass these environment variables using the CLI as well. Let's talk about command override. When you initially start your containers, you may want to execute some kind of a bash script or a shell script. Command override is nothing but a placeholder where you can put your script here. Okay. So if you type echo hello, it's gonna execute echo hello at runtime when the containers start. All right. So next is tags, and then finally review and create. It's gonna run through the validation, and I'll click on create. So here is our web application hosted in a container called as web apps. This is hosted in Northern Europe. And if you notice on the right hand side, it has an IP address and fully qualified domain name as well. So that's the DNS name. If you recall from the previous lesson, we did assign a DNS name to it. All right. So I will copy this URL and paste it in the browser to show you how the web app looks like. There you go. It was quick to show up on the web browser. Let's go ahead and do the same thing with the IP address. So I'm going to copy this to the clipboard, go to the browser and correct this and hit enter. It's going to, of course, show the same page. But the objective here is to tell you that accessing, provisioning web applications has been made much easier with the help of container instances. Of course, you may be thinking about how do I make my own custom image? How do I make my own custom web application? Well, we're going to take a look at that in a moment later on in the upcoming lessons. But for now, let's understand containers from the administration perspective. And slowly, as and when we understand those concepts, we'll drill down into the repositories, hosting images there, and customizations as well. So going back to the container dashboard, you got several statistics that will tell you the CPU utilization, memory, network bytes transmitted and received. So these are the very basic metrics that you will need as an administrator of containers to see the performance of your web application. When I click on containers, I would be able to see all the events that have happened with this container. So when the image was pulled, and what particular image was it, right? So we picked up ACI Hello World image. When did it start? When was it created? Several properties related to it as far as the compute power and specifications are required, and then all the logs that are generated on the go. One thing that will be very interesting for you is the connect button, which you can click on and connect to the bash of the container and run your own scripts from here. Looks like there were no problems with my container because the restart count is 0. That's something as an administrator I will always come here to see if my containers failed, if there was any problem, did it ever restart. Well, this is the place where I should come and check. Another important point is the identity section. So if you click on identity, you would be able to integrate with managed identities. So the advantage here of integrating with a managed identity is that you can have some kind of a credential stored in the Azure Key Vault, and then the managed identity can peek into the Key Vault to authenticate you against the cloud services. So what you're essentially doing is you're granting permissions to the container to go and get those credentials hosted in the Key Vault with the help of managed identities. At this point, it is still in preview. So let's go back to the overview section. And what I want to also show you is that you can stop the container, restart the container from here, also delete if required. So if you're doing the labs along with me, if you're done with the lab, go ahead and hit the delete button because the pricing of this container is per second. Although it's like fraction of a cent, it's not much. And of course, for a free tier subscription, it will be free. But the question is, can we deploy web apps in containers only with the user interface? Well, no. So what we're going to do in the next lesson is go ahead and deploy the container instances using Azure CLI and see how you can manage them as well. Let's get started with that then. All right, let's go ahead and spin up few containers using the CLI. To do that, I'm going to launch the Cloud Shell by clicking on this button here. You can move it up a little bit to make enough space for yourself there. Okay, so looks like it is ready. Clear up the screen, and now you can use the AZ commands. Say AZ container, and then you want to create, and the name of the container is, let's say, ecom app. Okay, there's a typo, ecom app. All right, and then the image that hosts my web application, let's say in this case, or just for an example, I'm going to use Microsoft slash ACI hyphen world. All right, so it's going to pick up that image and create my web application called as ecom app. I also want to make sure that it has a public IP, so I will say hyphen hyphen IP hyphen address. Okay, and it must have a public because I want to access it. Otherwise, the other options are private and none. Now, you may also want to add a resource group to this. So you'll type -G and type your resource group. I've got a resource group called as sales, so I'll type that and hit enter. You'll see how quickly a container instance will be created for you. So looks like ACI-world is incorrect. So what I got to do is correct it. So instead of ACI-world, it is ACI-hello world. Hit enter. It started running. There you go, it is ready. So it has created a container instance with the name ecom app. The OS type is Linux. It's in the resource group called as sales, and several other parameters of the container instance are available here. So let's go ahead and see if we can actually access it. So I'm going to take this public IP and right click and say go to the IP address. There you go. Our container instances are created and now they are ready to be accessed. Let's go back to the container instance page here, and I'm going to show you a few commands. So if you would like to list down all the container instances that you have in your resource group, let's say, so the command here is az container and then list. So instead of create, you're using list here, and then you want to list in the resource group called as sales, right? And if I hit enter now, it's going to show all the container instances that I have in my sales resource group. So one container instance is web apps, and if I scroll up slowly, I would also see my second container instance called ecom app. So these are the two container instances I have here. But then this is all gibberish. It shows all the properties of the application in a JSON format. But if you would like to see it in a tabular format, you can use the same command but add the following syntax called -O, which stands for -output in a table format. Hit enter, and it's then going to show in a nice tabular format. All right. You can then go ahead and pick up these IP addresses. So go to the page, etc. So you can play around that. So it's a much better way to represent the container instances you have. But you may be thinking, how do I customize this web page? How do I put my own content here instead of using the inbuilt ACI Hello World? Can I have my own images in the Azure Container Repository or somewhere in GitHub or in Docker Hub and then help me customize this web page? Can I go ahead and do that? Well, absolutely yes. So in the next lesson, let's go ahead and learn how you can customize this web page. How can you use your own custom images instead of inbuilt images and use the images in the Azure repository. In this lesson, let's go ahead and learn and understand how you can create your own custom images, how you can create your own custom web applications, how you can clone applications from GitHub. Let's say your customer gave you a GitHub repository and suggested you to clone the GitHub repository, customize that as per the requirements given in the requirements document. How would you do that? How would you create containers from the container repository is what we'll understand here. All right, so let's get started. I have the Azure CLI opened up here. So I'm going to launch this in a new session so that I get a better view and a better screen. All right, so while it is loading, I'm going to take you to another page, the GitHub page, where it's also considered as a sample repository. So all you got to do is go to github.com/azure-samples/ACI-hello world. Okay. So once you navigate to that place, you will see that it is a sample Node.js application. This is only for demonstration purposes and just for you to understand this whole concept better. So what we got to do is clone this GitHub into your own Azure subscription. So I will navigate to my Azure shell and then use the git clone command and paste the URL, which is github.com/samples/hello world. Okay. Now, Git executable is something that's already installed inside the Azure Cloud Shell, so you don't have to worry about installing it again. Okay. I'll hit enter, see what happens. It's going to take less than a minute to go ahead and clone it for you. Looks like it's already there. So let's see if there are any directories under that. We have a new directory called as ACI-hello world. So I'm gonna navigate to that folder. Okay, so that's not what we want. Okay, so we've got to navigate to ACI-hello world and do a dir here. Then you will see that there are exactly the same content that we had in the GitHub, right? The same thing. Now I'm going to show you one little thing here. So if you do code space dot and hit enter, it's going to take you to a folder view, let's say, where you can look at the contents of the file. For example, if you would like to look at the content of the readme.md in this web page, you will just click on it and then you see the content. But here you got to use code.dot to then look at the content and then click on this file. Thereby, you'll be able to view the content. All right. So code space dot is a command to view the content. Let's take a look at other files now. Now, if I navigate to the app directory, under that, I've got the main index.html. Now, this is the URL. For example, if you look at this, welcome to Azure Container Instances. Yeah. So you can go ahead and customize this, put your own HTML content right here. So what I'm going to do is change the title as, let's say, peaceful world. And you can also change the headers. You can show all your HTML skills and Node.js skills here. Okay, but I'm going to keep it simple. Serverless world here. Okay, and that's done. So what I can do is just go ahead and save this. And then there are other files that includes the index.js. There's a JSON file as well. And finally, there's a Docker file which controls which image should it use, where should it copy the files from, what is the working directory, etc. And also, where is the Node.js file located. All right, that's great. So let's go ahead and close this editor now that we have made the changes inside index.html. Right? Let's try to make an image out of this data. All right, so how I'm going to do that? And if I have to do that, where can I host it? Well, you should be hosting it inside a container repository, in Azure Container Repositories. So first thing that we're going to do is go back to Azure account and then create a container repository. Let's do that. Click on this and then in the search box type container registries. All right. Click on add and then just follow through the wizard to create a ACR or Azure Container Registry. My resource group is the same thing. Type a registry name as new app. Looks like new app is already in use. It must be unique. So I'm going to add some number and that's accepted. I'll leave the location as it is. Admin user, I want to enable this one so that as an administrator, I would be able to connect to the container registry. I can leave the SKU as standard, that's fine. Now under encryption, the CMK or customer managed keys is disabled for me because it's only available under the premium option. So if I click next now, then I will be able to use the customer managed keys. But because this is just a demonstration of using a container registry and we're still learning, I'll leave it as standard, move next and go pass through the encryption. Leave the tags, create, and then finally after validation, click on the create button. So I'll pause the video for now and get started again once the container registry is created and ready for use. Okay, so the deployment is complete. I'll click on the Go to Resource button, and this is my container registry. Under this container registry, I do not have any repositories at this time, so this should be empty. There you go. So the objective is to create an image from this content and host it here inside this repository. Then using that image, I want to create a container instance. Okay. I must also be passing certain access keys. Like I would be using this password and the username so that my container instance can connect to this container registry with the help of these set of credentials. I'm going to show that to you in a minute. But for now, let's go back to the Azure Cloud Shell and create an image and host it here. So that's the step one now. Okay. Let's get started with that. So I'm going to use the Azure CLI to build that image. The command will be AZ, and then I want to manage ACR. And what I want to do is build an image and call that image as, let's say, demo, as, let's say, customized hyphen image. And this will be hosted in my registry. And what's my registry name? My registry name is new app 121. I'm going to copy and paste it there like that. And then this will be a Docker file. Okay, let's hit enter and see what happens. All right, as you see, I've got an error. It does not have the source location, so it needs to know where the Docker file is. Now you can either type this entire path, or I can just do a dot next to Docker file that represents that the Docker file is located right here in this path. All right, that's what it means. So I'm going to hit enter again and see what happens now. So it has already started packaging it, creating a image, and then it's going to host that into the repository. And as you see the name here, new app 121.azurecr.io is the name, if you notice it carefully. Okay. All right. Preparing, pushed, should be there in a time. So while it is doing this thing, I'm going to be really curious and go back to my container repository, go to my repository and refresh this to see. There you go. So you have your custom image, and the CLI execution is also completed. All right. The name is customized-image. So my web content is right here. Now what I got to do is pull this image into Azure Container Instances. All right. With the help of this command, we were able to build the image and push it to the repositories, and from here we're going to pull into Azure Container Instances. So I will type container instances here and then start creating a container instance that connects to my Azure repo services. All right, so my resource group is sales, and create a new container app. I'll call it as creative apps or something. Leave it as Western Europe. And this time I'll be selecting Azure Container Registry. And if you notice, it has automatically picked up the registry here because that's the only registry we have. The image is automatically selected. Image tag is also selected. So if you wonder what that is about, I will just navigate to the container registry and show it to you. So this is my container registry. Scroll down, and then under repositories, you got the image, right? You click on the image further, then all the versions of that image will be listed. So it could be V1, V2, V3, and the latest as well. So as developers keep on modifying this image and start making changes to it, you will have different versions to it. You can deploy different containers with different versions. In this case, I've selected the latest version, which is nothing but an image tag. Alright, so we have already discussed these options when we started this discussion about container instances in the previous lessons as well. I'll click on next and then give it a public DNS name. Call it as creative apps. Alright, leave it as port 80, advanced, and finally click on create. Alright, the deployment is submitted. I will hit the pause button and resume once it is completed. Looks like the deployment of container instances is complete. Let's click on go to resource and then pick up the public IP address or the DNS name. I'll copy this and then go to the browser, paste it there, and see if we get our customized web page or not. There you go. So it now has our custom page, which is welcome to Azure Serverless World. That's what we type inside the code. And then in the title as well, it says peaceful world, if you notice that here, right? So that's what we typed in the code. Now, it just means that there are different entities that are connected here. And those entities are Azure container instances and then the images which are hosted inside the container registry. The developers will go ahead and modify these custom images as and when it is required, as and when there is a requirements document. And this can be done with the help of commands that are available here. So you modify the code, update it, create an image, update to the container repositories or the container registry, pull it from here to the container instance and start hosting your web application. That's how quick that is. Traditionally, you had to spin up multiple virtual machines and then create applications, install dependencies, and all that stuff, which was really cumbersome. But in today's world, with the help of containers, this has become a really easy ball game, at least from the administration and the infrastructure perspective. Let's do a recap of what we did so far. Till this point, we've created certain containers, container instances, exposed them on a particular port, in this case, port number 80. We also had a public IP address, a DNS name, couple of containers, and all of them were responsible to host our web application. Let's try to draw certain diagrams and understand this better. So what we have is a container one, let's say my ecom app that was created, and it had its own Azure container registry. That's where we pull the image from. We also hosted another app as well. We call it as web app, and then it was pulled from another container registry. What we could have done is that instead of creating multiple container instances, we could have created both of them in the same container group. So now I'm introducing you to another concept called as container group. A container group is a collection of containers that are running on the same host machine. So all of these containers in that container group will be sharing the resources, will be sharing the network, the storage volumes, and also a life cycle. So if you go back to the concept of Kubernetes, we have something called as a pod. Container group is a similar concept to what we have a pod in Kubernetes. In this case, a container group is hosted on a single host machine. It has been assigned a DNS label name. It is exposed with a single public IP address on a particular port. It can contain multiple containers. One can be listening on one port and another listening on a different port. Each of these containers will be pointing to a particular volume or multiple volumes as well. So the containers inside the container group are independent entities. Container groups can share an external facing IP address, maybe one or more ports on that IP address, and then a DNS label with a fully qualified domain name as well. There are different scenarios of hosting multiple containers inside the same container group. And those scenarios would be, let's say you would like to host a web application in one container, and another container may be pulling the latest content from the source control. Or let's say you want to have the application in one container and logging done in another container. So the logging container will have the logs and metrics that are sent by the main application and writes them to a long-term storage. If you would like to have monitoring done within the application set, maybe you will have a monitoring container as well. So the monitoring container will periodically make requests to the application to ensure that it's running and responding correctly. And if required, it may also raise an alert. How about databases? So you may have a front-end container and a back-end container. The front end is serving the web application on a particular port, and the back-end is retrieving and serving the data to the front-end web application on a different port. So these are the common use cases or common scenarios for hosting multiple containers in the same container group. Let's understand the importance of Docker and the terminologies used in the Docker world in the next lesson. Let's try to understand Docker as a platform and what it includes and the benefits it offers for a full-scale deployment of a web application in Azure. Docker is a platform that enables the developers to host applications within a container. By this time, you know that a container is essentially a standalone package that contains everything that is needed to execute a piece of software. And when I say everything, it includes various entities like the application executable code, the runtime environment as well. So for Windows based applications, you can think of .NET Core. It will also include system tools and various settings that will require for an application to work. The Docker platform is available on both Linux and Windows and can be hosted on Azure as well. The key thing that a Docker provides is a guarantee that the containerized software will always run the same, regardless of whether it's hosted locally on a Windows machine or a Linux instance or in the cloud on Azure. This means that the software that can be developed locally within a Docker container can be shared with various other resources like the QA team for testing purposes and then deployed to production in Azure Cloud. Once it is deployed to Azure Cloud, the application can easily be scaled up and down using the Azure Container Services or even the Kubernetes services. There are various terminologies used in the Docker world. For example, a container, container image, build, pull, push, and the Docker file. Most of these terminologies have been used in the previous lessons, but then let's talk about it to help you gain a better understanding of these terminologies. You should be familiar with various key terms that are used in the Docker world. These terminologies will be helpful for you to manage Docker and container instances to create, build, and test containers. To start with, let's try to first understand what containers are. You might have heard of this term several times during this course. So, what is a container? Container is an instance of a Docker image. It represents the execution of a single application or a process or a service. It consists of the contents of a Docker image, an execution environment, and also a standard set of instructions. When scaling a service, you create multiple instances of a container from the same image. Container image refers to a package with all the dependencies and information required to create a container. The dependencies include frameworks and the deployment and execution configuration that a container runtime uses. Usually, an image derives from multiple base images that are layers stacked on top of each other to form a container's file system. Keep in mind that an image is immutable. It cannot be changed or modified once it is created. What is a build? A build refers to the action of building a container image based on the information and context provided by its Docker file. There could be additional files in the folder where the image is built. You can build images by using the Docker build command. Push and pull. Well, pull refers to the process of downloading a container image from a container registry. Push, on the other side, is the process of uploading a container image to a container registry. What's a Docker file? Docker file refers to a text file that contains instructions on how to build a Docker image. It's like a batch script. The first line states the base image, and this can be followed by a set of instructions that are required to install programs, or could be you copy the files, and so on until you get a working environment you need. That brings us an end to the Docker terminology section. Let's go ahead and learn more about Azure Kubernetes services. And as and when we get along through this particular module, we'll learn more about various features of Kubernetes services and also the architectural portion of AKS. Kubernetes is a rapidly evolving platform that manages container based applications and also their associated components like networking and storage. The focus of Kubernetes is on application workloads. Kubernetes provides a declarative approach to deployments, which are then backed up by a robust set of APIs for management operations. You can build and run modern, portable, microservices based applications that benefit from Kubernetes orchestration and managing the availability of these application components. Kubernetes supports both stateless and stateful applications as the teams progress through the adoption of microservices based applications. Kubernetes is an open platform, and hence that allows you to build your applications with your preferred programming language, preferred operating system, your own set of libraries, or even the messaging components. You can use your existing continuous integration and continuous delivery tools to integrate with Kubernetes to schedule and deploy the releases. Azure Kubernetes Services provides a managed Kubernetes service that reduces the complexity for deployment and core management tasks, including coordinating upgrades. The AKS cluster masters are managed by the Azure platform, and you only pay for the AKS nodes that run your applications. AKS is built on top of open source Azure Container Service Engine, also called as an ACS engine. AKS makes it simple to deploy a managed Kubernetes cluster in Azure and also reduces the complexity and operational overhead of managing Kubernetes by offloading much of that responsibility to Azure. As a hosted Kubernetes service, Azure handles critical tasks like health monitoring and the maintenance of the clusters for you. In addition, this service is free. You only pay for the agent nodes within your clusters and not for the masters. There are several features of Azure Kubernetes services which we must talk about before we start to talk about architectures. Let's talk about the features of AKS in the next lesson. In this lesson, we will learn about the various features of Azure Kubernetes services. AKS is flexible as far as deployment is concerned. So you got number of deployment options. You can deploy an AKS service with portal, command line, and even with a ARM template that could be written with JSON or with Terraform. When deploying an AKS cluster, the Kubernetes master and all nodes are deployed and configured for you. When you write that ARM template, you can also write several detailed settings as far as networking is concerned, or if you'd like to integrate with Azure Active Directory, or maybe write some monitoring metrics into it so you can configure it during the deployment process. The AKS clusters also support role-based access controls, and that means that the AKS cluster can be configured to integrate with Azure Active Directory. In this configuration, Kubernetes access can be configured based on Azure AD identity and also based on group membership. The container health gives you performance visibility by collecting memory and processor metrics from containers, nodes, and also from Kubernetes controllers. Container logs are also collected, and that data is stored in your log analytics workspace. You can then take a look at the workspace using the portal, CLI, or using APIs. As the demand for resources increase, the nodes of the AKS cluster can be scaled out to match the demand. If the resource demand drops, nodes can be removed by scaling in the cluster. AKS scale operations can be completed using the Azure portal or also using the Azure CLI. Azure Kubernetes Services offers multiple Kubernetes versions. So as new versions become available for you, your cluster can be upgraded using the portal or from CLI. During the upgrade process, nodes are carefully managed and drained to minimize disruption to running applications. The HTTP application routing solution makes it easy to access applications deployed in your AKS cluster. That means when you enable the HTTP application routing, it will configure an ingress controller in your AKS cluster. So as the applications are deployed, publicly accessible DNS names are automatically configured. For applications that need lots of graphics, AKS supports the creation of GPU-enabled node pools. Azure currently provides single or multiple GPU-enabled virtual machines. GPU-enabled virtual machines are designed for compute-intensive, graphics-intensive, and visualization workloads. There are a lot of tools that we have in today's world as far as development is concerned. Kubernetes has a rich ecosystem of development and management tools. So think about Helm, Draft, or the Kubernetes extension for Visual Studio Code. These tools work seamlessly with Azure Kubernetes services. There's another service called as Azure Dev Spaces. You can use that and it will provide a rapid, iterative Kubernetes development experience for your teams. With minimal configuration, you can run and debug containers directly in AKS. An AKS cluster can be deployed into an existing VNet. In this configuration, every pod in the cluster is assigned an IP address in the VNet, and that can then directly communicate with other pods in the cluster and also with other nodes in the VNet. Keep in mind that these pods can connect to other services in a peered VNet and also to on-premise networks over ExpressRoute and site-to-site VPN connections. We all know about the container registry by now, so the AKS clusters can integrate with the Azure Container Registry for a private storage of your Docker images. Let's understand more about Azure Kubernetes Services by learning about clusters, master nodes that are Azure managed, and the customer managed nodes as well that will be actually running your application workloads. Let's do that in the next lesson. A Kubernetes cluster is divided into two components. One of them is Azure managed and the second one is customer managed. The Azure managed nodes are also called as a master node or a cluster master node. When you create an AKS cluster, a cluster master is automatically created and configured. This cluster master is provided as a managed Azure resource, which is abstracted from the user. There is no cost for this cluster master. The other part of it, which is also called as a customer managed node or node pools, is there to run your applications and support the services. An AKS cluster, which is an Azure virtual machine that runs the Kubernetes node components and container runtime, contains of multiple nodes. They are the kubelet, kubeproxy, and container runtime. Let's talk about what these components do. The kubelet is a Kubernetes agent that processes the orchestration requests from the cluster master and also schedules the running of requested containers. The kube proxy handles the virtual networking of each node. The kube proxy routes the network traffic and manages IP addressing for services and pods. Now, this is the component that allows containerized applications to run and interact with additional resources such as the virtual network and storage. In Azure Kubernetes Services or AKS, Docker is used as the container runtime. Nodes of the same configuration are grouped together into something called as node pools. A Kubernetes cluster contains one or more node pools. The initial number of nodes and sizes are defined when you create the AKS cluster, which also creates the default node pool. The default node pool in AKS contains the underlying virtual machines that will eventually run your agent nodes. Let's talk more about AKS networking in the next lesson. It's really important to have some kind of a communication between the various components of an application, specifically when we're talking about microservices and a container based microservices approach. When we are developing modern applications, we need to have some kind of a communication that will tie those components and make them work together. We're talking about networking. AKS networking will allow the applications to communicate with each other so that the Kubernetes nodes are tied up to a virtual network so that some kind of an inbound and outbound connectivity for the pods can be established. Always remember that inside the node you have the pod, and then inside the pod you got your container running the application. That's the sequence. In the previous lesson, we did speak about kube proxy, right? So the kube proxy component runs on every node, and this is responsible to provide all the networking features that Kubernetes services needs. There are various concepts that we have inside the networking of your Azure Kubernetes services. So we've got to talk about services, Azure virtual networks, ingress controllers, and network policies. Let's talk about services first. So let's say you built an application on Kubernetes containers in Azure, okay? Now you would like to expose that on some port onto the internet or maybe on the intranet, right? So this is done with the help of the first component called as services. Services will logically group the pods so that you can allow direct access via an IP address or a DNS name on a specific port. So remember, when you'd like to expose your application on a particular IP address externally or internally on a specific port, you would need services. Okay. For a larger application, you may also need a load balancer. You may need to configure complex application routing. This is achieved with the help of ingress controllers. And if you'd like to have some kind of a security and filtering of the network traffic for the pods, this is possible with the help of Kubernetes network policies. That's just a high level view of what each of these components mean. But as we drill down further into other sections and as and when we do the labs, you will understand them better and you will be able to connect all of these dots together. At this point, these services and these new terminologies may be overwhelming for you, but stay connected as we do and progress through the classes, you will understand them better. Let's talk about services a little bit. Every pod is listening on its own port number, right? So let's say you got multiple pods, pod 1, pod 2, and pod 3, and is listening on a particular port, let's say port number 80. And all these pods are running on a particular node, right? Or you also call it as a cluster node. So what we're essentially doing here is we are creating an internal IP address for use within the AKS cluster. This is good for internal applications only. So if you'd like to route your internal traffic within the Kubernetes cluster between the cluster nodes, you need the cluster IP. Every node has a port, and that is called as a node port. It's important to create a port mapping on the underlying node. So this will allow the applications to be accessed directly with the node IP address and its port. So by now we have two things, the IP address of the cluster node and the node port as well. If your application becomes bigger, becomes complex, and you would like to distribute the load, what you need is a load balancer. The load balancer will distribute the load between the cluster nodes. So you create an Azure load balancer, and this can either have an external IP address or an internal private IP address, depending on how you want to configure. The backend pool of the load balancer will be the cluster nodes or the Kubernetes nodes. You can have all kinds of load balancing rules written on the load balancer so that the incoming traffic can reach the appropriate application on the desired port. The load balancer can be exposed externally or can be routed just internally. It's important to have a specific DNS entry so that the application can be accessed through a name easily. And like I said earlier, the IP address of the load balancer can be dynamically assigned or even use a static IP address. When you use an internal load balancer, it will always and only have a static IP address. But when a load balancer is an external load balancer, it will have an external IP address or a public IP address. Applications that will be hosted on the Kubernetes services will need some kind of a volume to store and retrieve the data. You can use a local storage or a fast SSD storage. At times, you may need the data, and in other instances, when pods are deleted because of low workload, the volumes may also get deleted. So there are different scenarios for retaining your data and not retaining your data. Let's talk about the different use cases here and various core concepts like volumes, persistent volumes, storage classes, and persistent volume claims. Kubernetes treats your individual pods and containers as ephemeral. That means something that is disposable, something that's not permanent or is temporary in nature. With this approach, the applications will be using the data as necessary. The volumes will be represented to the container to store, retrieve, and persist data only for a certain duration of time. With volumes, you can present Azure disks or Azure files to the Kubernetes cluster. Azure disks can be used to create a Kubernetes data disk resource. You can go ahead and create an Azure disk from the Azure portal and choose various options you have, including the premium storage, which is backed up by the high performance SSD, or choose a standard storage for regular HDDs. For most of the production and development workloads, you would use a premium storage. You can also use an Azure file, which is used to mount as a SMB 3.0 share by the Azure storage account to the pods. When you use Azure files, you can share the data across multiple nodes and pods. But there may be situations where you may want to retain the data for a longer period of time. That is, even if the pod goes offline or is deleted, you may want to retain the data. That is what a persistent volume is. A persistent volume is something that is existing even after the life cycle of a pod. What we spoke earlier was about volumes that will be defined and created as part of the pod life cycle only until the pod is deleted. Persistent volumes will exist beyond the lifetime of an individual pod. You can again continue to use Azure disks and files to provide that persistent volume. Let's try to understand a storage class. A storage class provides a way for an administrator to describe the classes of the storage they offer. We know that Kubernetes is open source and is used by several other providers, including Amazon and Google and Azure as well. So, different kinds of cloud providers provide different kinds of storage. In Azure, we would like to use Azure Files or Azure Disk for that matter. So, how would you present it to the Kubernetes cluster? It has to be written in the JSON format. So if you look at this particular code here, it is saying that the storage class is Azure file. You can also present it in the form of a disk as shown in this code. So if you'd like to present a disk or a file, you need to represent that in the form of a storage class. But what will happen if you do not present anything in the code? Well, there is a default option, and the default storage class will then be picked up. The default storage class will be Standard Azure Disk. Standard Azure Disk is backed up by HDDs. It is a cost-effective storage and is ideal way for dev and test workloads. But if you would like to get more performance, you would like to have an SSD based high performance, then you have to define a managed premium storage class. So there are two kinds of storage classes that Azure Kubernetes Services offers. The default and the second one is managed premium storage class. Let's understand another aspect of volumes here. This is called as persistent volume claims. Now, when you define storage, you need to define what is the minimum resources that the volume requires. What kind of access mode the volume should have. For example, do you want it like a read write once, or read only many, or read write many? What kind of storage class names would you like to give to it? These are called as metadata of the storage, because you would like to define who the provider is. For example, is it picking up from NFS or is it Azure Disk? If you're using other cloud providers' disks, for example, Google or Amazon, then you may want to define, is it a GCE persistent disk or AWS Elastic Block Store? What is it? Capacity information about the persistent volume resources and the capacity is also defined. The persistent volume claims is also defined here. What is your reclaim policy? What it means is that what happens when corresponding volume is deleted? Would you like to retain it, delete it, or recycle it? These kind of attributes are defined in the persistent volume claim section. Let's talk about the security concepts for hosting applications and clusters in Azure Kubernetes services. We deal with lots of sensitive data when hosting data in containers. There could be passwords, credentials, data at rest, and data in transit is what we are referring to, and both of them must be kept secure. By now, we know that there are two entities in Kubernetes that we are referring to. One is a master, and other is a node where your applications are hosted or containers are hosted. It's important that you go ahead and keep both of them secure, because that is how you will protect your customers' data that is running the application workloads in the AKS clusters. In this lesson, we'll talk about the security of the master node, the node security, how do you handle the cluster upgrades moving from one version to another version, how do you handle the security for the data in transit with the help of network security, and finally, how do you handle the sensitive data in the pods? And it could be accessing credentials or certificates or keys with the help of Kubernetes secrets. So, how do we handle the master node security? We know that Kubernetes master components are part of managed service, and this is all managed and maintained by Microsoft. Every AKS cluster has its own single tenant, dedicated Kubernetes master, and it provides the API server, scheduler, internal DNS name resolution, etc. Hence, the security of it is also managed and maintained by Microsoft. By default, this Kubernetes API server will be using a public IP address and also a fully qualified domain name. If you integrate this with Azure Active Directory, you will be able to grant role-based access controls and granular permissioning using the Azure AD permissioning model. Let's talk about node security. These nodes host your applications in the pods. These nodes are all managed and maintained by you. They could be running on Windows operating system, or it could be running on Linux operating system depending on the application that you have hosted. Their operating system security, updates, and configuration is all your responsibility. Microsoft Azure updates the operating system security patches to the Linux nodes on a nightly basis. But if a reboot is required, it is not done automatically. You need to perform the reboot yourself, and you will get a notification for that. Every node is monitored for the latest security updates, and those daemons are continuously monitored as well. Just like your master nodes, you can grant permissions to these nodes and even to the pods using role-based access controls and integrate that with Active Directory. Keep in mind that the security is for the entire cluster, including master and the nodes that you run your application. They are not for individual nodes. What about cluster upgrades? For security and compliance purposes, it's important to use the latest feature sets that are available in the AKS cluster. Azure provides the required tools to orchestrate the upgrade of an AKS cluster and its components. There have been different versions of Kubernetes in the past, and these upgrades keep on happening depends on how the cloud provider would like to manage it. It's important to have the Kubernetes version at the latest level. The upgrade orchestration includes both the Kubernetes master and the agent components. There is a process called as a cordon and drain process, and this is also called as an upgrade process, which works on the master and the agent nodes. Let's talk about the process of how these nodes are upgraded. So when a new node is deployed into a node pool, that node runs the latest operating system image and patches. One of the existing nodes is identified for the upgrade if the nodes are running at the older version. Pods on this node are gracefully terminated and scheduled on other nodes in the node pool. The node with the older operating system or older patches are deleted from the AKS cluster after the pods on it are gracefully terminated and moved to the other upgraded nodes. The next node in the cluster is cordoned and drained using the same process until all nodes are successfully replaced as part of the upgrade process. This ensures that all nodes are updated and upgraded at the same level. Network security, data in transit. Security for the data in transit is handled by network security. So you will have connectivity to your on-premise networks as well with your Azure AKS cluster. You may have site-to-site VPN or an express route which connects back to your on-premise networks. Kubernetes ingress controllers define how the connectivity should be, whether it should be private using internal IP addresses or should be accessible over the external networks as well. On top of it, you can use the Azure network security groups to write the rules and define the source, destination IP ranges, ports, and protocols that are allowed or denied access to the resources. Finally, the Kubernetes secrets is responsible for injecting the sensitive data into the pods on your nodes. The sensitive data can include credentials, keys, or anything that is secretive in nature or something that protects your information in the volumes. So when you create a secret, you will have the APIs and access keys connecting to the Kubernetes cluster so that the secrets can be requested for. Secrets are only provided to the nodes that have scheduled pod that requires it, and secrets are not written to the disk. They are accessed directly from the key vault and written to the temp storage or temp ephemeral volumes. And once the pod has accessed the secret and even the other pods do not need it, then that secret information is even deleted from those temporary folders. By using the secrets, you really do not have to store that information inside the pod or in the YAML files. Instead, you will be requesting for the secret information, which is stored on the Kubernetes API server on the master node as part of your YAML manifest. This approach ensures that the entire transaction is secure and the secrets are not exposed to unauthorized entities. It's a recommendation to never have the secrets committed to the source control or hard code the secret information in the YAML manifest. Azure Kubernetes Services and Azure Active Directory, they work together to provide you with the authentication and also securing the Kubernetes clusters. You would use role-based access controls so that you can grant permissions to users and groups and thereby letting them access the resources that they need. This will result in enhancing your security, enhancing your permission structure, and thereby it will be securing the application workloads and also customer data. Let's try to understand the various core concepts involved in authentication and assigning permissions. So in the upcoming lessons in this module, you will learn about Kubernetes service accounts. How does Azure Active Directory integration happen? How do you assign permissions using role-based access controls? And certain new terminologies like roles and cluster roles, role bindings and cluster role bindings. Some of these terminologies may be totally new to you at this time, but that's fine. As and when you get introduced to these concepts, you will start absorbing them. And when we do the labs and apply these concepts, you will be able to join the dots and get a better hang of it. Let's get started. The master node always hosts the API server, and that API server is responsible to host your service account as well. One of the primary authentication methods is a service account that is hosted and managed on the Kubernetes API server. The credentials for the service account is also stored on the API server in Kubernetes secrets. This will then allow the service accounts to be used by the pods and also to communicate back and forth with the API server. Most of the API requests provide an authentication token for the service account or a normal user account. So there are two methods you can authenticate yourself against the Kubernetes containers. One is using the service account or using a regular normal account. When I say normal account, it's nothing but a traditional way of accessing your applications or services. This could be a developer accessing the application or a human administrator accessing the services and processes. The identity management solution is provided by Azure Active Directory. This is because Kubernetes itself does not host your regular accounts or passwords. So these credentials are stored and managed by Azure Active Directory, whereas the service account is stored and managed by the Kubernetes API server hosted on the cluster master. Azure Active Directory always stays in the spotlight when it comes to authorization and authentication. For Kubernetes, it is no different. AKS supports Azure Active Directory integration so that the associated users and groups can then connect to the cluster. Azure Active Directory would be the single source for account management and security. To obtain a kubectl configuration context, a user can run AZ-AKS get-credentials command. And then when the user interacts with the kubectl to manage the Kubernetes clusters, they are prompted to sign in with Azure AD credentials. In Azure AD, you define roles and then assign users or groups to these roles. The roles or the role definitions are then scoped to a particular resource or a resource group or a subscription. Let's chat about roles and cluster roles, okay? So roles are used to grant permissions within a Kubernetes namespace. So before you assign permissions to a user using RBAC, you define these permissions with the help of a role. You will then assign the users to this role. Cluster role is a bigger concept. So if you like to apply permissions to the resources across the entire cluster and not a specific namespace, you will then use cluster roles. So the role is there to assign permissions within a namespace,
And cluster role is there so that you assign permissions across the entire cluster.
All right, that's a lot of theoretical concepts about containers and Kubernetes. Let's go ahead and get started with the lab exercises for Kubernetes. And as and when we encounter new things, I'll start explaining about it. So let's get started with that. The first thing that I'm going to do is to go ahead and create a Kubernetes cluster. To do that, we can go ahead and click on create a resource. Although there are multiple ways of doing it, you can go to all services or use the search box and then type Kubernetes there, just like the way we did earlier. But then I'm just trying to show you a new way here. So type Kubernetes and then select Kubernetes service and click on create. All right, so as always with every other service, we'll fill up these values and walk through the wizard, okay? I'll leave the subscription as it is and choose my resource group. It looks like I don't have a resource group to host Kubernetes. I'll go and create a new one here, call it as dev rg or something and click OK. All right, that's going to be my new resource group. Give a Kubernetes cluster name as well. I'll call it as web app hyphen cluster. Okay, and then I'll leave the region as it is, but you know that there are so many regions to choose from. Okay, the latest version today is 1.1.73, and if I'm using this for production purposes, I will not use it because it's still in preview. I'll choose something less than 1.17, which is 1.16. Okay, what is the DNS prefix? It is automatically selected for me, but then if you do not like it and if you would like to have your own DNS name prefix for your cluster, feel free to get rid of it and type your own. Okay, I'll leave it as it is now. The next option is the node size. There are a range of node sizes to choose from here. So depending on the workloads that you're going to run on your Kubernetes cluster, you might want to pick and choose the amount of CPU, the memory, etc. For now, it's okay. I will leave it as it is. So what I have now is DS2 V2, which is giving me 2 vCPUs and 7 gigs of memory. Okay, I'll leave it as it is. That's fine. And just in case if there isn't a problem, you can always go ahead and upgrade this to next level. All right. The next option is scaling. As you run applications in AKS clusters, you may need to increase and decrease the amount of computing resources. So as the number of applications grow and they change, the number of underlying Kubernetes nodes may also need to change. So you may also need to quickly provision a large number of additional application instances. And that's what scaling means. In real production environments, you'd always like to have this done automatically instead of choosing a manual option. But yeah, you can always manually scale the replicas, the pods. You can test how the replication responds to a change in available resources. But then that's not the recommended method to have manual scaling of pods or nodes. It's good to have automatic scaling done. So under the scaling section, you got two options. There's virtual nodes and then there is, I will leave both of them as enabled and then click on next. The next option is role-based access control. Would you like to have a role-based access control integrating that with Active Directory? Yes or no? So let's say you got a lot of developers accessing your application and you would like to grant them access so that they can then connect to the clusters and deploy and publish those applications into the cluster. Well, how would you grant access to them? It's only possible with role-based access control and hence it's important to enable it. By now, we know that in Azure Kubernetes services, there is a managed node. It's totally managed by Microsoft. But then, if that node or your nodes have to communicate with each other back and forth and perform some activities, how would that happen? It would happen with the help of a service principal. Now, this service principal would be used to manage your cloud resources which are attached to your cluster, right? So I will let it create a service principal name and click on next to choose the networking options. Let's walk through the various options we have under networking. At times you may need to grant public access to your cluster. If that is the case, then you will leave the private cluster option to disable. But if you would like to grant it a private access, that means the Kubernetes cluster is routable within your LAN environment or within your VNet, then that's when it goes to enabled. Let's talk about the HTTP application routing. Now this particular option here, if you choose to yes,
it will deploy two things. One is an ingress controller, and second is an external DNS controller. Okay, so the ingress controller is exposed to the internet by using the Kubernetes service of type load balancer. The ingress controller watches and implements the ingress resources and creates routes to the application endpoints. The second point, which is the external DNS controller, watches for any Kubernetes ingress resources and creates a DNS A record in the cluster specific DNS zone. By enabling HTTP application routing, you are making it easy to access applications that are deployed in your AKS cluster through the internet. Because here you're configuring the ingress controller and letting it create a publicly accessible DNS name for application endpoints. Okay. All right, I'll leave it as yes. The load balancer type is standard in this case. By default, I've got the network configuration switched to advanced, and that means that I will have the options to create my own virtual network. What does that mean? It means that you're hosting your Kubernetes cluster in one of the subnets that you're defining here. You cannot toggle it back to basic now because if you flip back to one of the previous sections, I've selected virtual nodes here and it is enabled, right? I will flip it to disable for a second, go to the next section under networking, and you'll see that we now have the options to switch to the basic option, which means that the IP addresses to the clusters and the nodes will be given by Microsoft and cannot be managed by us. If I choose advanced, I will then have the options to create my own VNet and host my Kubernetes cluster in my own subnet. You can also assign what IP address ranges it should have. This is great for environments that have on-premise to Azure VNet connectivity with a point-to-site, site-to-site, or even express route connection where you would like to have private routing or private connectivity between on-premise and the resources in Azure. Okay, so I will leave these options as is. Let it create a virtual network with the name dev.rg vnet. That's my subnet name. That's fine. So I'll accept these starter blocks and click on next. Under the monitoring section, would you like to have Azure Monitor integrated with Kubernetes cluster? You can see how beautifully things are getting integrated into other services to get the most benefit out of monitoring, let's say, or even role-based access control under the authentication or networking features under the networking section. So I do not have to write my own API calls or any other procedures to integrate with other services and get the benefit out of them. So by just moving this to yes or toggling to yes, I will have the monitoring of my CPU, memory, network statistics, performance statistics, all thrown up on the dashboards of Azure Monitor. And then I'm able to create a workspace in log analytics as well to do better troubleshooting, to do better performance analysis and diagnostics about the behavior of my Kubernetes cluster. All right, so that's my log analytics workspace, and I'm going to have Kubernetes container monitoring on at this time. I'll move on to tags. You know what tags are? You can have a CMDB here, so you can type owner is Rob and you type Rob's email address and then their department or maybe their cost center, and then you can charge them back because you got the cost center here, right? This is more for governance purposes and compliance purposes as well. Great, so finally click on review and create, let it validate my options, and if everything is green, everything is good, I'll click on create. All right, so this create button is enabled for me. I'll click on create. It will take a couple of minutes to deploy that cluster in my subscription. So I'll pause the video for now and connect again once it is ready.
Alright, so the deployment is complete. Let's click on this go to resource button and take a look at the options we have here. Now this Kubernetes cluster has a server address which is specified in the top right hand side, and the name is web app-cluster-dns followed by its own suffix. Okay, so as deployed in Northern Europe, if you go ahead and click on node pools, you will see that I've got a cluster of 3 nodes that we use to deploy this Kubernetes service. Now if I click on these 3 nodes further, you will have the options to scale it further. Now at this point, I've got the scaling set to manually, but you can always set this to automatic or auto scale. So when it auto scales and creates new instances, it's going to create new nodes of the same specifications as we selected earlier. I'm going to click on cancel, talk about upgrade. So when we are creating the Kubernetes cluster, at that point in time, we selected 1.16, but there was a newer version available as well. So if Microsoft sends you an email stating that the bugs in the Kubernetes clusters have been fixed, new features have been released, here is where you can come and upgrade your cluster. We already spoke about scaling when you're talking about node pool, so let's jump to networking section. And what we see here is that when we were creating the Kubernetes cluster, we selected the custom network. So this is deployed in our own network. This gives you an advantage here because you can now connect this Kubernetes cluster or your web application hosted on the nodes to your on-premise network. So if you got a point-to-site connectivity or a VPN or express route connections, these applications will be able to communicate directly with your intranet services. Okay, if you have implemented the concept of DevOps, integrating with dev spaces has become much easier. You can do monitoring with Helm 3. So, as you see, there are a lot of integration tools that are available, and it will let you integrate with other Microsoft tool called as dev spaces. You will find the next option very interesting, but it's currently in preview. So, let's say you've got your application hosted somewhere externally on a third party repository, like let's say GitHub, Bitbucket, or your own external Git. Then you can integrate your web app with GitHub directly. So your CI/CD pipeline can run through the GitHub, and anything that's hosted on the GitHub or let's say Bitbucket will be pushed to your web app, and that will be hosted as a web application. Right? And you got the monitoring options like insights, metrics, advisor recommendation, logs, and workbooks. So let's go ahead and host a web application there with the help of CLI. So in the next lesson, what I'm going to do is launch the Azure CLI and start running few commands to deploy a sample web application. What I'm going to do is use the quick start option guide available here. So if you navigate to this URL, docs.microsoft.com/azure/aks, and this URL that you see, you will see that there is a quick start lab document available for you. So what I'm going to do next is pick up this particular YAML file and show you how you can deploy this YAML file as a web application so that you will see something like this. So you will navigate to http:// the public IP, and then you will connect to the web application. All right, let's get started with that now. Okay, let's get started with the CLI method of deploying your web application on your existing Kubernetes cluster. All right, so I'm going to launch the Azure CLI, move it up a little bit to make enough space for myself in this console, and wait for this CLI to settle down. All right, so now that's ready. So the best part is that you really do not have to install the kubectl command here. So let's give it a shot. You can try the kubectl command on the CLI interface and hit enter and see what happens. If the kubectl command does not exist, of course it will error out, but then it gave a lot of suggestions and syntaxes available with kubectl. That means kubectl is integrated into Azure CLI and you do not have to install this explicitly. All right, so let's clear the screen. What I'm going to do first is to connect to my Kubernetes cluster. The command is AZ-aks and say get hyphen credentials. Okay. Now, my Kubernetes cluster is in a particular resource group, so I can either do hyphen hyphen resource hyphen group, or just type the shortcut here, just say hyphen G. That's also fine. So what is my resource group name? It's dev.rg. So I'll type it as it is, and then type the name of the cluster, which is hyphen hyphen name, and the name of my cluster is web app hyphen cluster. I'll copy and paste this guy here and hit enter and see what happens. All right, so I've got the context set. So next time, any command that I'm going to run will be running under this context and connecting to this cluster. So this command is really helpful when I am actually running certain commands against a specific cluster. If you have lots of clusters running in your production environment, let's say. Okay, so now I'm going to say kubectl
and then say get nodes. So it's going and connecting to web app hyphen cluster and getting the nodes that I have under this. How many nodes do you see? Well, there are 3 nodes. It's exactly the number that you saw under the node section. So if I go to my Kubernetes cluster under node pools, there are 3 nodes, right? That's what we are able to see with the kubectl command. Remember that not everything is manageable using the UI, but yes, the CLI is very powerful and you can manage everything with the help of that. Okay, so I've got 3 of the pools, they're ready, and all of them have the same version. Okay, so now let's go ahead and host that application. What I'm going to do is go to my quick start template, copy this, okay, and then open a file. So for this, you need to know a little bit of Linux, not a lot, but you need to know certain commands called nano editor, or how do you open the VI editor, okay? So I will use nano and then type the name of the file, just call it Azure, or let's say web app, okay, .yaml, just give it an extension, YML. Hit enter, and then you will go ahead and paste it from the clipboard. Okay, so my YAML file is right here. The whole thing has been copied. So just in case you are new to Linux and new to Nano, don't worry. There are a lot of help files available. And then I'm going to follow through these. So just hit Control X on your keyboard to exit out of this. Okay, Control X. And then it says, do you want to save it? Just say Y on the keyboard and hit enter. Okay, so that is saved. So if you do cat to web app.yaml, you should be able to see all your content. That means that this whole content that you see inside this sample web application, this file, is inside my file called as webapp.yaml. Now it's time to push or apply this file to my Kubernetes container. How do I do that? Well, I'll clear the screen first and then use kubectl command, use apply, and then I'm going to say apply the contents in my file, which is nothing but azure.yaml. Okay, so that's ready. Hit enter to see what happens now. All right, is there a typo? If I do ls, all right, it's not azure.yaml, it is webapp.yaml. So there was a not a typo but a blunder. Okay, it's a mistake. So web app, this should work now. Okay, so this created a backend for me. All right, services were deployed, deployments is done. So this output really tells me that the deployments and services were created successfully. Now it's time to test the application. Okay, let's do that. How do you test it? Let's use the kubectl command again. So I will say kubectl and say get service, and the name of the service is Azure-vote-back. So I'm gonna copy it as it is to minimize any typos, and then say watch. With this, I'm actually monitoring the progress with the help of the --watch command. And the reason is that it is still being deployed. It is not completed. If it completes, you will find an external IP address. And that's why it is set to none. All right, we now have a public IP here. So it took about 7 to 8 minutes to get that public IP for us. But now that is here, I can just do a Control C to stop the watch here. Okay, so that's stopped. Now I can copy this public IP address, navigate to my browser and paste it there. And now what you can see is the web application being pulled up from our Kubernetes container. We did not host a virtual machine. We did not host a web app in the app services. This is an application hosted in your containers, on your pods, on your nodes, which is being managed by the Kubernetes cluster. And you can play around these buttons here. It just calculates the number of cats and dogs we have, depending on how many times you click on each one of these buttons, and finally reset that. But just a sample application, which then lets us know the power of the Kubernetes cluster. Let's try to understand more options we have inside the AKS. What's important to understand is the monitoring aspect of AKS as well. So if I scroll down to the bottom a little bit and then click on Insights, on the right hand side, you will be able to see several metrics that are related to containers. You can see the total CPU utilization of the node, the memory utilization of the node as well. And as you scroll down, you will find several metrics that will be helpful for you to troubleshoot and identify those performance issues that the developers and the end users are reporting on. If you scroll up to the very top, there's an option to view all the clusters. Once I click on it, it will take me to the containers option. We can then click on the monitored clusters. Now, since we have just one cluster here, I'm able to see just that. But let's say in an enterprise environment, you've got lots of Kubernetes clusters running. You will be able to see all of them in a one single dashboard. So it tells you the health status of all the Kubernetes clusters running in your environment. Okay, so I'll click on this further to show you the power of monitoring and getting insights about it. So now if I click on containers here, okay, so these are all the containers with various namespaces here. The container that we are interested in is the one that we deployed, which is Azure-vote back. Now you can get more granular statistics about it by clicking on view live data. Keep in mind that this is just in preview. It's not fully tested. So be watchful when you're using this option. We cannot fully depend on the options that view live data provides. Okay, so eventually it's all about looking at the live data that's being routed to your web application. So if you click on events, you will be able to see everything that has happened with your web application so far. So 17 minutes ago, the Azure vote-back container was started, created. It also pulled up an image called as Redis image, and this is there inside the YAML file. Let me go back to the YAML file and show it to you. If I scroll down, it does specify somewhere that it is picking up a Redis image. There you go. You have the Redis image right here. Okay, so the image is Redis. Now going back to the cluster here. Now on the right hand side, I will again click on view container logs instead of analytics. Let's just click on that. Now this is something that the network operations center or the developers may also be interested in, to see the entire logs of your application, right? So that is how integration with log analytics really helps. So this screen that you see is coming from the log analytics. Here I'm able to see detailed information about all the changes, configuration changes, connections that have happened and occurred with this container can all be seen here. Okay, these are the detailed logs. So for an application developer, someone who's troubleshooting, these logs are really important. All right, that's about deploying applications in containers. I will go ahead and delete this. So I'll click on overview, finally click on delete, and yes, and that is letting me delete my nodes and clusters and everything that we did so far. Hopefully this has been informative to you. Thank you.
Learning any tool or technology starts with knowing its architecture and terminology. It could be any design or it could be any technology in the world. We must first understand the terminologies used in it and also the underlying architecture. Sometimes these architectures are complex, just like the Kubernetes. Kubernetes architecture has several terminologies. There are several components that work with each other to accomplish a common goal. In this lesson, let's learn and understand the nitty-gritties of the Kubernetes architecture. Essentially, the Kubernetes is also called as K8s. The number 8 represents the 8 characters between K and S. Every Kubernetes cluster has at least one master node and also has certain worker nodes. To break down things and to make it simple, let's just assume that the master node is like a class teacher and the worker node are like students. The entire application design, let's call it as a school. I'm just using these terms like class teacher, students, and school to make things simpler. The class teacher coordinates the activities with the students and makes them work so that they accomplish a goal or maybe pass an exam. Kubernetes architecture works just like that. In this example, we have one master node and three worker nodes. But in enterprise environments, it can scale up to 5,000 nodes. And there can be multiple master nodes as well for fault tolerance and resilience purposes. The worker nodes can be physical machines or virtual machines, but here we're talking about Azure-based Kubernetes implementation. And that means they will be virtual machines which are managed by Microsoft. All of these nodes work together to become a cluster. You might have heard of this term called as a pod, a container. Let's understand what it is. A pod is a scheduling unit in Kubernetes. Each pod has one or more containers. There may be multiple containers as well in the same pod. Containers are runtime environments for containerized applications. So you run applications inside the containers. Containers are designed to run microservices. Containers are not designed to run monolithic applications. Let's talk about the master node. The master node is responsible for managing the whole cluster. We use the analogy of a class teacher here, right? So here the master node will ensure that all the nodes are healthy. So it performs a health check and configuration of the nodes as well. So if one node fails, it moves the workloads to other nodes. So it's a master who detects the failure. Kubernetes master is also responsible to expose your applications to the internet, manage the load balancer, and also scale the nodes. Always remember that the containers are hosted in the pods and the pods are hosted on the nodes. Let's shift our focus to the Kubernetes master node. The Kubernetes master node is responsible for managing the entire cluster. It coordinates all the activities in the cluster and communicates with the worker nodes. So when you first deploy Kubernetes, it deploys four components along with it. First is the API server. The API server is the entry and exit point for the entire cluster. So if you want to manage, provision, display any Kubernetes object, then it has to go through the Kube API or the Kubernetes API. It is also responsible for exposing all the APIs. We interact with this API server using a command called as kubectl. The second component here is the scheduler. Scheduler is responsible for scheduling pods across multiple nodes. So depending on the information in the config file, the pods would be deployed. So let's say that you mention the CPU as 1 core, memory as 4 gigs, the disk size as 20 gigs, and then several other constraints. And then you pass this artifact to the API server. The scheduler will look for the appropriate node that meets this criteria and then deploys it accordingly. The next component is the control manager. Now, when this is deployed, there are four other controllers that get connected with it. That's a node controller, replication controller, endpoint controller, service account, and token controllers. Just keep in mind for now that these controllers are responsible for the health of all nodes. Finally, the etcd or etcd. The etcd is a key value lightweight database. It is a central database to store current cluster state at any point in time. So the components for the Kubernetes can query the etcd to get the current state. So this is considered as a single point of truth for the state of Kubernetes cluster. Now let's shift our focus to the worker node. The worker nodes can be any virtual machine or physical server where containers can be deployed. Every node runs a container runtime, such as Docker or Rocket. There are two other Kubernetes components also required to communicate with Kubernetes master. And this is very important. They are called as the kubelet and the kube proxy. The kubelet is a primary node agent that runs on every node. This ensures that the containers in the pods are healthy, and if they are not healthy, then the pods are restarted. And if the issue is with the worker node itself, then the node failure alert is sent and it tries to create the pods on a different node. Let's talk about the kube proxy. Kube proxy is a critical element in the Kubernetes cluster. This is responsible to maintain the network configuration. It essentially maintains a distributed network across all pods, all the containers, all the nodes as well. It also exposes the services to the outside world. Now, this is the core component for networking in the Kubernetes cluster. The worker node also hosts pods and containers. As we know, that pod is a scheduling unit and each pod will host one or more containers. It is ideal to host multiple containers in the same pods when they are dependent on each other. If you would like to interact with these containers, you do it via the pod. Containers provide a runtime environment for the applications. You can run processes, services, and other applications inside the container. Containers are designed to run microservices and not for monolithic applications. So the four components inside the worker node are kubelet, kubeproxy, the pod, and the container. Besides that, you can have other plugins as well depending on your application requirements. Now, let's combine both the master node architecture and the worker node and take a look at it together. In most cases, the master node does not contain any containers. It just manages the worker nodes. Remember that the Kubernetes supports up to 5,000 worker nodes inside one cluster.